Welcome, my friends! I'm so excited because in this video we get to talk about the weighted mean. So let's go ahead and get started. In a weighted mean, some observations count for or occur more than other observations. Here's an example related to test scores. We have 9 students who scored a 90, 16 students who scored an 80, 15 students who scored a 70, and 5 students who scored a 60. To find the mean, we need to add up all the scores and divide by the sample size. But like we said, we are calculating a weighted mean, meaning that some observations are going to count for or occur more frequently than the other observations. In this case, this applies to the scores. Some of the scores happen more frequently than others, so should have a higher weight, such as the 80, and some of the scores happen less frequently, like the 60, and therefore should be given a lower weight. If you wanted to see this written out, we have something like this. We have 90, 9 times, we have 80, 16 times, 70, 15 times, and 60, 5 times. So we really have to add up each of those the appropriate number of times in our numerator of the mean formula. And then we have to divide by our total sample size, which is just adding up all of the numbers of students. So that's 9 plus 16 plus 15 plus 5. This could be simplified to 9 times 90 plus 16 times 80, etc., all divided by 45, which is the denominator. If you simplify this out, you should get this result, eventually this result, and then at the very end, you should get approximately 76.44. So really, the weighted mean, or the weighted average score, taking into consideration the number of students who scored each of these 4 scores, is 76.44. In this example, we were trying to find the mean score of a student, and score was weighted based on the number of students that had each score. To find the weighted mean, we took each weight multiplied by the corresponding score and added them all together and divided by the sum of the weights. In formula form, that looks something like this. We use x bar with a subscript w to represent the weighted mean, and to find this, we take each weight, in this case, each number of students, and multiply by the corresponding x value, in this case, the score. Once we've multiplied all of them together, we add them together, and then we divide by the sum of the weights, or in this case, the number of students. Sometimes students can have a hard time differentiating between the data and the weights, and it does make a difference, because if you mix up the data and the weights, you'll be adding up the incorrect values in your denominator, and therefore you will get the wrong answer. The data always relates to the variable you are trying to find the mean for. In this case, we were trying to find the mean score. So the data, or the x values, are represented by the score. And therefore, the other variable is going to be representing the weights, in this case, the number of students. Let's take a look at a weighted mean calculation with percentages. Suppose someone is either going to make 0 out of 2 free throws, 20% of the time, 1 out of 2 free throws, 50% of the time, or 2 out of 2 free throws, 30% of the time. Let's say that we would like to find the weighted mean number of free throws made. Now we can't just do the simple arithmetic mean by adding up 0, 1, and 2 and dividing by 3, because that does not consider the percentage of the time that each of these free throws are made. The 1 happens more often than either the 2 or the 0, so it should be given more weight. 0 happens the least frequently, so it should be given the least weight. In this case, we are trying to find the weighted mean for the number of free throws made. So that means that our variable x is going to be the number of free throws made, and therefore the weight is going to be the percentage of attempts. To find the weighted mean, we can take each percentage, which is represented by the weight, and multiply by the corresponding number of free throws made, add them all together, and then divide by the sum of the weights. What we will get is 0.2 times 0 plus 0.5 times 1 plus 0.3 times 2 divided by 0.2 plus 0.5 plus 0.3. You may want to write these in decimal form like I have on the right rather than percentage form. If you multiply all this out, you're going to get 1.1 divided by 1, which is equal to 1.1. So this means that 1.1 out of 2 free throws are made on average. Now you may have noticed that the denominator summed to 1 and therefore did not really change our answer at all. And that's always going to be the case with weighted means with percentages. So sometimes you can just think about only calculating the numerator of the formula if you're doing a weighted mean with percentages, since that denominator is not going to change your answer. Alright, so here is a problem for you to try. It says approximate the mean waiting time using the midpoint of each class in the following frequency distribution. So we have the waiting time that someone is going to wait, which is looking like anywhere from 0 to 34, and then we have the frequency in our second column. Now, when they say use the midpoint, they say, well, we don't actually know exactly how many individuals had each of these different waiting times. We just know that we had 4 individuals that waited anywhere from 0 to 6 minutes, or 9 that waited 7 to 13 minutes, etc., right? So since we don't know exactly what each value is, we can just use the midpoint. And to find the midpoint, we can just add up the 2 values in each of these categories and divide by 2. So 0 plus 6 is going to equal 6 divided by 2 is going to give us 3. So we would use a 3 for the waiting time for our first category. Or you do 7 plus 13, which would be 20, divided by 2 would give you 10. So you would use 10 for your second category, right? So go ahead and see if you can calculate the weighted mean. But be very careful to make sure that you have correctly identified your value for x, the data, and also w for the weights. All right, my friends, that's all I had to say here related to the weighted mean, so hopefully you were able to find it useful and enjoyable, and I will see you in the next video.